Let's take a look at bonding, and we're working on naming ionic compounds and writing formulas for ionic compounds. And this time we're going to really focus on writing formulas. To do this well, you're going to need to be able to identify the correct charge on an ion and learn how to balance charges. Now, how do I write ionic formulas? Ionic compounds must be charge balanced. And what this means is the number of positives and the number of negative charges must be the same. If I look at something like sodium chloride, I have one positive and one negative. Potassium sulfide, I have two positives and two negatives. And calcium chloride, two positives, two negatives. So the total positive charge must always equal the total negative charge, no matter what ions are involved. This is the rule for ionic bonding. And this is why we don't need prefixes, because there's only one way to make the charges balance. So I'm going to break this down into a few steps. And we're going to use magnesium hydroxide as a working example. And we're going to take that name and convert it into a formula. The first thing I need to do is figure out what the ions are for my name. So I'm going to use the periodic table or the polyatomic ion list. I have magnesium, and that's on the periodic table. And based on where it's at in group 2, I know that magnesium is a positive 2 charge. Now, hydroxide is not on my periodic table. It's on my polyatomic ion list. And hydroxide has the symbol OH with a negative. And that negative is for everything. So I'm going to write those. That's step 2. Magnesium was +2. The hydroxide, I put parentheses around it to show that all of it was -1. Now, this isn't balanced. I have two positives, but only one negative. So I'm going to balance it by adding more ions until I have the same number of positives and negatives. In this case, I need another hydroxide. Now I have two positives and two negatives. The last thing to do is write the formula. And to do that, I'm going to just put the symbols together, and I'm going to use subscripts for ions where there's more than one. So I only have one Mg, so I'm going to write Mg, but I have two OHs, so I'm going to use the subscript 2 for the OH. Now, there are special rules for transition metals. Transition metals will always have their charges next to the name, so I won't have to look that up on the periodic table. The iron 2 tells me that this iron has a +2 charge, and that Roman numeral always goes with the metal. So let's practice writing formulas for ionic compounds. Let's start with sodium sulfide. So step 1, find them on the periodic table if you can. Here's Na, that's sodium. So the sodium, based on where it's at, is a +1 ion. Sulfide is sulfur. You got to work it backwards. Remember, we changed that ending to IDE in the name. And sulfur tends to have a -2 charge. Now, I see they're not balanced. I'm going to need another sodium so that I have two positives and two negatives. Now it's balanced, and I can write my formula. Na2S. All right, let's try nickel 3 oxide. So nickel is a transition metal. I don't know what the charge is based on that, but the 3 tells me the charge for the nickel. So this is nickel +3. Oxide is oxygen, which has a -2 charge based on where it's at. And now I need to balance it. 3 and 2 don't go evenly into each other, but they do go evenly into 6. So I'm going to need 2 nickels, that's +6, and 3 oxygens for -6. And I'll get the formula, Ni2O3. Okay, let's try lead 2 cyanide. Lead, again, they're telling me the symbol, so I don't need to find it. They're telling me it's +2. Cyanide is on my list of polyatomics. It's got a -1. So I'm going to need 2 of the cyanides, and I can write PbCN2.